Hi everyone. Welcome to section 10.4a. This should be a nice short sweet one. It's on radical equations. So, first thing we need to talk about is what is a radical equation. So a radical equation is any equation that contains a radical. You might be surprised by that, right? So an equation means you've got an equal sign. A radical means you've got a square root. And anytime we've got that equal sign, we typically can solve them. So we're going to be able to find the solution or solutions to radical equations. So an example is the square root of x plus 6 equals 22. That's a radical equation. It's got an equal sign, so it's an equation. It's got a radical or a square root. This is a pretty simple example of a radical equation, but it's still a radical equation. So the first thing you want to do is isolate the radical or the radical expression. So in this example up here, the square root of x is the radical expression. So if we wanted to get that by itself, we want to get rid of the plus 6, right? What do we do to get rid of the plus 6? Subtract 6 from both sides. So we have a square root of x equals whatever 22 minus 6 is, which I think is going to be 16. You might take more than one step. You might need to subtract then divide. You might need to do something like that, but it's always going to be to get that square root radical all by itself. Once you do that, you're going to square both sides of the equation. You may need to FOIL. We'll talk more about that. We'll do an example of one today. But if we're going to square both sides, because we know that to get rid of a square root, we square. They undo each other. And our last step, if we have a leftover equation, we're going to solve it. We could get back to quadratics, quadratic formula, or this should say formula, by the way, not equation. Either use a quadratic formula or factor. But in this particular example, we don't need to solve the leftover equation because the square root of x squared is x. 16 squared, we're just going to do the math. And if I'm remembering right, I think it's 256. Somebody check me and make sure that I am right. So that didn't seem so bad, right? So let's do a couple examples. So again, your key is always isolate first and then square. So let's do example B and C. I like B and C. So example B. Do you see the radical expression that we need to isolate? So here's my square root sign, so that means I'm going to need to get rid of the 3 and the plus 8. Which one's got to go first? Always subtract first, right? Add or subtract first. So when I subtract 8, I've still got a 3, a square root of 2x minus 6 equals whatever 14 minus 8 is, which I think is a 6. Now the 3's got to go, because I still don't have this square root by itself. So to get rid of that timesing by 3, I'm going to divide by 3. This is old-fashioned equation solving. But now, here's the thing. Once I divide by 3, I've got 2x minus 6 left, all underneath the radical. 6 divided by 3 is 2. So now I can finish, or keep moving, by getting rid of the square root sign. How do I get rid of a radical? Square both sides. So squaring and square rooting undo each other, so I'm just left with that radicand, 2x minus 6. Over on the right-hand side, 2 squared is 4. And now I'm looking at another old-fashioned equation to solve for. I want to get the x by itself, so I'm going to start by adding 6. So I've got 2x equals 10. And what's my last step? Which gives me what for my x value? I also like a 5. So I've got first to isolate the radical. So to do that, I got rid of the 8. There we go. I got rid of the plus 8. I divided by 3. Once I get that radical by itself, I'm going to square both sides, and then I'm going to solve what's left over. Right? Letter C, I wanted to do this one because, first of all, do I need to do any work to isolate my radical? If I look at this is my square root, right? There's nothing on the same side of the equal sign with the square root, like how we had the 3 and the plus 8 on that last problem. So I'm ready to square both sides of the equation. So I'm going to square this, I'm going to square this, only I'm going to use parentheses, because on that right-hand side, do you see what's going to have to happen here? So on this side, I'm going to have an x plus 2 written out 2 times, and I'm going to have to do FOIL. I know that you guys have this down, so I end up with an x squared plus 2x plus 2x plus 4. I always do this as side work. I don't like it to mess up the middle of my problem. So x squared plus 4x plus 4 is what I get over here. Let me move this for a second. I'll make that littler. Is what I get for the right-hand side of my equation. The left-hand side of my equation, square rooting and squaring undo each other, so I've got an x squared minus 3. It looks like it could get messy. I've got x squareds, which is my big clue that I've got to get everything to one side equal to 0. So I start by subtracting an x squared. What do you notice? Good news, everybody, when you subtract x squared from both sides. There's no more x squareds left, right? So I've got a negative 3 equals 4x plus 4. And then I'm going to just solve this. I'm not going to worry about everything on one side because the x squareds went away. I don't have to do quadratic formula. I don't have to factor. So I would subtract 4 here to get this x by itself. You could do this a different way if you wanted, or switch the two sides of the equation. Negative 7 equals 4x. My last step. Is it okay to get a fraction for an answer? X equals negative 7/4. If you're going to a calculator, x equals negative 1.75. I'll probably keep it as a fraction. So really, this is review, practice, throwback Thursday for solving equations. So lesson summary. What I would like you to do is write me an example, any example, of a radical equation. You cannot use one that's already on this paper. Don't be copying something down. Practice problem, solve that. I notice I have a couple things to do before I isolate my variable, or isolate my radical with the variable, but you should get a nice neat number when you do this problem, a nice neat large number when you do this problem. Have a great day. We'll see you next time.